In today's note, we are going to do a factoring review. So we're going to look basically at kind of the steps we need to go through anytime we're given a question and we're asked to factor. And the steps that we should be going through to make sure that we're factoring polynomials completely is basically working through all the different types of factoring that we have. The first thing we want to start off with is common factoring. Every lesson that we looked at, or all the different types, we always talked about common factoring first. Now that may not always be the case, but it's always the first place you want to start or look at. Next, what you're going to look at is difference of squares. Right? That's an easy one to look at because really there's only two terms. They should be perfect squares and they should be a minus. So that's an easy one to look or notice for first. The third thing, if we don't have two options or two terms, if we have a trinomial, we're going to look at a perfect square trinomial, right? We're going to look for that pattern. Is the first term a perfect square? Is the last term a perfect square? Is the middle term the square roots of those two and then doubled, right? So understanding the patterns of a perfect square. If it's not one of those, then we're going to move on. Is it a simple trinomial? Do we have a variable squared as our first term, or is a value 1? And if it's not that, is it a complex trinomial? And then if it's nothing after that, then there's chances are that we've already factored it completely. So we're going to look at the first one here, 45m squared minus 80. So the first thing we want to do is common factor. And if I common factor, I can see that I have at least a value of 5 that is divisible into both of these numbers. So I'm going to take a common factor of 5 out, and I'm left with 9m squared minus 80 divided by 5 minus 16. The next option I'm going to look at is difference of squares. I do have two terms in this bracket. 16 is a perfect square, 4 squared. 9 is a perfect square, and m squared is also a perfect square. So this is also a difference of squares. So I'm going to keep the 5 there because I common factored it out. And then I know for my pattern for difference of squares, if I square root the first term, I get 3m. Square root the last term, I get 4. So my pattern then is 3m minus 4, 3m plus 4. And now I've completed my factoring. There's nothing else that I can factor. There's not a trinomial, right? It's already factored. Moving on to the next one. Again, the first thing we want to do is common factor. I can see here that I have a value of 5 that is a common factor. So I can take that greatest common factor of 5 out, and if I do that, I end up with 25x squared plus 10x plus 1. So now I've common factored. I'm going to look next. Is it a difference of squares? No, it's not a difference of squares. Is it a perfect square trinomial? Well, let's check. Can I take the square root of the first term? I can, and I get 5x. Can I take the square root of the last term? Yes, square root of 1 is 1. If I do 5x times 1 and then double it, does it equal my middle number? It does. So this is a perfect square trinomial. So the 5 is going to stay out there in front. I'm going to put my first term, 5x. It will be plus 1 because of the sign on the second term, and then squared. And I've factored it completely now. Moving on to the next one. 6x squared plus 30x minus 216. Again, the first thing you want to do is common factor. Let's check. So 6 is my lowest number. So does 6 go into 30? It does. Does 6 go into 216? It does as well. So I can common factor a 6 out, and I'll be left with x squared plus 5x minus 36. Next, I'm going to look, is it a difference of squares? No, it is not. Is it a perfect square trinomial? It does look like it because 36 is a perfect square, but because of that negative, that doesn't fit our pattern, right? Every perfect square trinomial, the last number has to be a positive. So in this case, it is not. Is it a simple trinomial? Or is that value in front of the x squared 1? In this case, it is. So this is going to be my simple trinomial. So this is going to be my product and sum method. So I'm looking for two numbers that multiply to negative 36 and add to 5. And when you work through this, we should see that our factors will be 9 and 4. And in order to get a negative product and a positive sum, the 4 has to be negative. So 9 times negative 4 is negative 36. 9 plus negative 4 is positive 5. When I go through and finish factoring then, it'll be x plus 9, so the first factor, and then x minus 4, the second one. And here I've completely factored, right? So again, it's just the process of going through these steps. Check for common factoring. Check for a difference of squares. Check for a perfect square trinomial. Check for a simple trinomial. Check for a complex trinomial. Moving on to D, y squared plus 25. So first things first, I'm going to check to see if we have a common factor. In this case, do we have a common factor? No, there's nothing that will common factor between them. So next I'm going to move on to a difference of squares. I do have two terms. They are both perfect squares, right? Square root of y squared is y. Square root of 25 is 5. However, the key thing here is that we have a plus in the middle, and a difference of squares had a minus. So it's not a difference of squares. It can't be a perfect square trinomial because it's only two terms. Can't be simple trinomial. Can't be a complex trinomial for the same reason. So this one is not factorable. Which again is okay. That may be something that you come across, just terms where they're already factored or they can't be factored. Moving on to E, again, same steps. Check for a common factor. My lowest value is 4, so my only options for factors are 4, 1, and 2. 4 and 2 can be divided into 20, but they can't be divided into 21, so I can't common factor anything here. Is it a difference of squares? No, it's not, because it has two terms. Is it a perfect square trinomial? In this case, no, it is not, because even though 4x squared is a perfect square, 20 is not. Is it a simple trinomial? It is not, because the value in front of the x squared is not 1. So that means we're left with a complex trinomial. So here we're doing a modified product and sum method. We're looking for two numbers that multiply to give us 4 times 20, or 80, and they add to give us 21. So if we play around, 10 and 8 don't work, but we do have 5 and 16 that work. So 5 and 16 are going to be my two factors. So when remember when we factor complex trinomials, we're going to use decomposition. So 4x squared This 21x is going to be broken down into my two factors. Again, we talked about it doesn't matter which order they go into. So I've broken that down 21x into 5x and 16x. Now I'm going to focus on factoring by grouping. So I'm going to look at the first two terms. I see there's an x that's common. I'm left with 4x plus 5. In my second pair, there is a 4 that's common. So a positive 4, and then I'm left with 4x plus 5. This works out because I can see that I have the same bracket, which is the goal. And I have my leftovers. So when I factor this again, I'm left with 4x plus 5. And then my leftover is x plus 4. And this is factored completely. So I've gone through my steps, I've gone through all the possibilities, got to the end, and I factored it completely. F. So looking at F, is there anything we can common factor? In this case, we cannot. So we can't common factor. Is there a difference of squares? In this case, no. Is it a perfect square trinomial? It does look like it. 4x squared is a perfect square, but minus 4 is not. So you do have to keep in mind of that minus. So that is not. Is it a simple trinomial? No, it's not, because the value in front of the x squared is 9. Is it a complex trinomial? It would be, or it is, but if I look at my second term, we have negative 2k. So believe that's a typo, so for sake of argument, let's assume that that is positive, or that's an x, and let's treat it as a complex trinomial. So P is going to equal a sum or a product of 9 times negative 4, which is negative 36, and the sum has to be negative 2. So we're looking for two factors. In this case, we can play around. 6 doesn't work because it would cancel out. 12 and 3 don't work. 9 and 4 don't work. So again, there's no easy way to come up with the factors. You kind of just have to play around with it. You may be able to recognize some factors right off the bat. But I think we've come up with almost everything that we can think of, and we can't find any factors that work. Because we tried 1 and 36, that didn't work. We tried 2. And 18, that didn't work. 3 and 12 don't work. 4 and 9 don't work. 5 is an option. 6 and 6 don't work. 7 isn't an option. 8 isn't an option. 9 we have already tried. So again, going back, so then once we hit 9, because we've already used it once, we're just going to be hitting the same numbers over again. We'll come back to 12, 18, 36. So none of these options work. We can't find any factors. So it is not factorable. So even if we didn't take out that typo and change that x, it wouldn't have made a difference. It's not factorable either way. So we can go back. We tried it as a complex trinomial. We tried to factor it, but we found that this was not factorable. G, 27x squared minus 48. So again, the first thing we want to do is common factor. And in this case, we can common factor. It may not be obvious right away, but we can common factor out a 3. So we get 27, or not 27. So 27x squared divided by 3 is 9x squared minus 16. Now right off the bat, because in our brackets we only have 2 terms, we can cross off our last 3 options. And now we have to check, is it a difference of squares? So can I take the square root of the first term? I can. Can I take the square root of the second term? I can. Is the sign between them minus? It is. So it is a difference of squares. So that means it'll be 3, and then we have 3x minus 4, 3x plus 4. So just taking those 2 square roots and plugging it into our pattern for a difference of squares. H, 30x squared minus 155x plus 140. So here I'm going to hope that I have to common factor because the numbers that I'd be dealing with otherwise would be very large. I should see that I can at least factor out a 5. So if I factor out 5, I'm left with 6x squared minus 31x plus 28. And here we can see that there's no more common factors in this trinomial, so we need to move on. Is it a difference of squares? No, it is not, because I have 3 terms. Is it a perfect square trinomial? No, it is not, because 6x squared and 28 are not perfect squares. Is it a simple trinomial? It is not, because the value in front of the x squared is not 1. So we have to assume or try it as a complex trinomial. So that means we're looking for a product of 6 times 28, which equals 168. And the sum has to equal negative 31. So here we should be looking for 2 negative numbers. But let's focus on finding numbers that multiply to 168. So we should kind of start with kind of large numbers and work our way up. So maybe let's try 16, nope. 18, no. 19, no. 12 does work, but 12 and 14 do not. Add to negative 31. (21) and 8 do not. So again, there's no trick to it. You just kind of have to keep plugging away at it. And if you keep plugging away, we should find we get 24 and 7 as our 2 factors. And if we need to make them negative because our sum is negative 31. And 2 negative multiplied to give us negative, or to give us a positive. So after a while, we found our factors. So we can break up this middle number, or now we can work into the decomposition. So 6x squared, put a square bracket, so 6x squared minus 24x minus 7x plus 28. I'm going to look at my first 2 terms and my last 2 terms, so now I'm going to factor by grouping. So 5 is still there as a common factor. And I should see that in the first one I can common factor out a 6x. So I'm left with x minus 4. The goal in the second bracket is to get x minus 4 as well. So in order to get a positive x, I need to factor out a negative 7. and that leaves me with x minus 4 again. So it's usually, once we can common factor the first pair, it's usually easy to common factor the second pair because we know what we want to get in the bracket. We should see that we have a common bracket between these two terms. So if I common factor, or if I common factor those out, go back to round brackets, we have x minus 4 times 6x minus 7. So again, this one was a little bit more complicated just because we're dealing with large numbers, but we worked our way through. We took care of common factoring first, narrowed it down to complex trinomials, and then worked our way through that to figure out our factored form. And the last one, we have x squared minus 6x plus 24. So is there anything we can common factor? There is not. Is it a difference of squares? It is not. Is it a perfect square trinomial? Well, let's check. Square root of x squared is x. Square root of 64 is 8, I believe. It is 8, and if we do 8 times x times 2, we get 16x. Oh, but unfortunately that's not our middle number. So it is not a perfect square trinomial, which is fine, right? We went through the steps, we checked, it was almost close, but the middle number didn't work out, so it's not a perfect square trinomial. Is it a simple trinomial? Yes, it is, because the value in front of the x squared is 1. So here we're just going to use our regular product and sum method. So two numbers that multiply to 64 but add to negative 6. So we're looking for two factors to add to negative 6. So 4 and 16 do not work. And again, going through it all, we think we'd come up where there are no factors that work out to this. So this is not factorable. So we worked through all our steps. We've got ourselves down to a simple trinomial. And when we tried to factor it, we couldn't find any factors that worked out to a product of 64 and a sum of negative 6. So we got that this was not factorable. And again, that's fine. They don't always have to factor, but as long as we're going through the steps to narrow it down to the correct form or process that we have to go through to then check to see if it's factorable, that's the main goal. Along with that, going down, here is a flow chart that we can use. Now I know it looks a little complex, so don't feel like you have to rely on this. If you're comfortable with that kind of step-by-step thing that we were just doing, the common factor, difference of squares, perfect square, simple trinomial, factoring, or then complex trinomial. Basically, this is what it's going through. All right, so start at the top. Does a greatest common factor exist? Common factoring, yes. Okay, we'll factor that out. Then if not, no, we end up to the same or the next spot. Does it have two terms? Yes. Is it a difference of squares? Right? If it is, here's the pattern that we have to use. If it's not factorable anymore for what we're going to be learning this year. Going all the way back up, if it has more than two terms, does it have 3? Well then yes. Is it a perfect square trinomial? So again, use that process to check. And if it is, then we can use our pattern. If it's not, we have to check, is it a simple trinomial, or the a value in front of x squared 1? If yes, then we can go over here and we see what our method is to go through it. If it's a complex trinomial, so the a value in front of x squared is something other than 1, we have our steps down here. If it does not have 3 terms, we didn't really talk about this one, but you can always refer back to factoring by grouping, which again we have done before with the complex trinomial. So again, this is more kind of the process just kind of mapped out. You don't have to use this if it's a little confusing, but at least you can see all the used ones and it will show you the general forms. I would say stick to, if you're a little like more simplified, stick to this process. Look for common factor, look for difference of squares, look for perfect squares, simple trinomial, and complex trinomial. And that is basically the review of factoring.